So when we look at that word logistics, sometimes our brains play tricks on us and we think it says logic, but it doesn't. It's logis with an S. Okay, this is logistic growth. It's a certain kind of growth. So yesterday, or last time on Friday, we talked about two kinds of growth. We talked about growth, and a growth equation looks like this, where you start out kind of slow, and then you have this rapid increase in growth. We also talked about decay. Decay starts out with this rapid decline, and then sort of levels out like that, and that is a decay. So when we come back from Thanksgiving, we're going to learn how to graph the things that we've been working on. Right now, you just have to know generally kind of what the shape is. So growth will shoot rapidly upwards, decay will shoot downwards really quick, and then level off. Logistic has a different type of shape. It starts out really slow and then has this rapid increase of growth where it shoots up, where you're growing really rapidly. Maybe you call that your growth spurt. But then logistic growth always levels off. And then it has no more growth anymore. So it starts really, really slow and then has this rapid period of lots of growth, and then it levels off. And that's what makes the difference between a growth, a decay, and a logistic. A growth one will grow and keep growing. A decay will decay and keep decaying. But a logistic has sort of a change and a bend in its graph. The formula for a logistic, you've actually seen problems. We talked about a rumor last time together. Okay, you've seen problems like this, 500 over 1 plus 7e to the negative 0.4x. Or you might see numbers like 150 over 1 plus 8 times 3 to the 2x, something like that. Those are all called logistic forms. It's when you have a whole number on the top and then 1 plus something else on the bottom. So the format for logistic is this. We say m is on top, 1 plus ab to the exponent on the bottom. Anything in that form where you have a whole number m on top and a 1 plus and then some kind of exponential form with the x in the power on the bottom, that is called logistic. And the letter m is an important number. Okay, this letter m right here stands for max. And it tells you the level of where it's going to level off on an equation. So if I give you a problem and I say, well, what's the maximum going to be? You should be able to just look at the number, whatever the numerator is, and tell me what the maximum value is going to be. Okay, so an example of how that would work would maybe be a question that showed up like this. Let's talk about Dallas. Okay, they've studied Dallas. They've done population studies on Dallas. This is what they've come up with. 1,301,642 over 1 plus, this is actual data, 21.6 e to the negative 0.05 t. Okay, this is the city of Dallas, not the suburbs of Dallas, just the actual city of Dallas. And they come up with this data all the way back to 1900. Okay, so they've been gathering data since 1900. You could be able to answer a couple questions from that problem. All right, A. What would the max population in Dallas be? 1,301,642. Now this is a prediction, okay, just in the city of Dallas, just downtown, not suburbs or anything. If you add the suburbs, it's way bigger. But the maximum for Dallas that they could handle with how much housing they currently have and how many jobs are currently there and things like that, that would be the maximum population for that particular city based on the data. Okay, part B. Okay, what was the population in 1900? Okay, that's a question. What's the population in 1900? Well, you're not just going to just drop 1900 into that equation. Okay, this is when the population is starting to be measured in Dallas in 1900. So instead of putting 1900 in, what actual value are you going to drop into that equation? Not 1, 0. Okay, and you don't even really need much of a calculator to do that. It looks scary. 1,301,642, 1 plus 21.6 e to the, and then it becomes e to the 0. And we all know what e to the 0 is, right? 1. So this becomes 1 comma 301,642 over 1 plus 21.6. That's it. So I guess you could use your calculator at that point to grab out, well, what's that number divided by 1,301,642 divided by 22.6? Like, what would that come out to be? That's going to be your actual value in the year 1900. Or